Algebra 2 notes, trig review number 3. So there are 6 trig functions, and so far we've just learned about sine, cosine, and tangent. We're going to look at their reciprocal function. Okay, so the reciprocal of sine would be the cosecant, and what we're going to do is just flip it over. So instead of opposite over hypotenuse, it's hypotenuse over opposite. Okay, secant is going to go with cosine, so it's the reciprocal of cosine. So it's going to be the hypotenuse side over the adjacent. And then tangent, instead of opposite over adjacent, it's going to be adjacent over opposite. So let's practice these with the one that we already started here. So I'm still on page 1. So abbreviation for cosecant would be CSC. So CSC theta. Again, it goes with sine. It's the reciprocal of sine, so we're just going to flip it around. It's going to be hypotenuse over opposite. The secant would be hypotenuse over adjacent, and the cotangent would be opposite, adjacent over opposite. All right, let's try another one here. Given the ratio for cosine theta, find the other 5 trig ratios. So cosine theta would be 2/3. So just let theta be one of your acute angles. It doesn't matter which one. So I make theta here. Cosine. So let's label our sides. So we've got opposite, hypotenuse is the longest side, and then adjacent is right next to theta. All right, so we are given that cosine is 2/3. Well, remember, cosine, that's ca. So that would be the adjacent side over the hypotenuse. So that means 2 is the adjacent, and the hypotenuse is 3. What would the opposite side be? So here's where we need to use that Pythagorean Theorem and go a squared plus b squared equals c squared. So then we can subtract the 4, and x equals plus or minus the square root of 5, but we don't need minus since we're talking side length. So this other side over here is going to be the square root of 5. All right, so what would the sine be? Sine, so opposite over hypotenuse. So we're going to say square root of 5 over 3. Tangent, TOA, opposite over adjacent. Square root of 5 over 2. And then these are just going to be the reciprocals. The only thing here is we can't leave that radical in the denominator. So this will be the one where we need to multiply by the square root of 5 over the square root of 5. So 3 square root of 5 all over 5 for the cosecant. Cosine, the reciprocal of 2/3 would just be 3 over 2. And then cotangent, we'll have to multiply by the denominator again. So 2 times the square root of 5 over 5. Okay? All right, let's jump to the back of the page. What to do if you have a special right triangle and you're trying to find trig ratios. So first thing we need to do is let's think of our special right triangle relationship. So if it's the 45, 45, 90, our legs are the same, in, and our hypotenuse is n times square root of 2. For the 30, 60, 90, we've got our short leg, our hypotenuse, and our long leg. So let's just let n be 1 in both of these scenarios, because these are ratios, so it doesn't matter if we let them both be 1 or let n's be 5s or whatever, it's still going to be the same ratio. So if I let n be 1, I'd have 1, 1, and 1 times the square root of 2. For the second one, if I let n be 1, I'd have 1, 2, and 1 times the square root of 3. So square root of 3. All right, now these ones you should be able to do without a calculator. Okay, so if I want to find the sine of 45, so if I'm starting at this 45, sine opposite over hypotenuse, that'd be 1 over the square root of 2. Remember, we need to rationalize that denominator. just like we did on the one on the front. So take it times the square root of 2 over square root of 2. Okay, cosine 45 is going to be the same thing. Adjacent over hypotenuse. And we still need to rationalize that denominator. How about tangent 45? Why don't you guys go ahead and pause the video and see if you can do these last 7 using our knowledge of the special right triangles. So go ahead and pause the video. All right, tangent 45 would be 1. The sine of 30, so if I'm starting at 30, what is opposite? That would be 1. Cosine 1 over 2, hypotenuse. Cosine 30, that'd be adjacent over hypotenuse, and tangent 30. When I start at 60, I need to change these around here. So if 60 is my starting angle, now square root of 3 is opposite and 1 is adjacent. So just be careful with that. All right, let's go ahead and look at your assignment. So for these first couple, you're just practicing kind of the nitty-gritty trig, figuring out the side lengths. So it's like 49 is my starting angle. So you can go ahead right away and label which one's opposite, which one's adjacent, and which one's the hypotenuse. And then I want to see the trig function. So make sure you show your work on these. So if I start at 49 degrees and I want to find x, it's kind of like cover up y for a minute. So if I'm just focused on x, AH tells me to use cosine. Okay, and then you could solve that. If I want to set up y, that means we don't want the x side. I'm going to set it up using opposite and hypotenuse, which would be the sine. So even though these seem like they're set up the same, they're going to give you a slightly different answer because you're using cosine there and sine on this one. Okay, so make sure this should be, when I say show your work, this is the work I need to see. If you want to show more, go ahead and show more, but show at least the setup. And then find your answer to the nearest 10th or 100th. It doesn't say in the directions, so either one's fine. Okay, so that's for the front. For the back, those two are just like we did in our notes. And then we've got some special right triangles. So try to do these ones without looking back at your notes and see if you can come up with it.